Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we're joined by Charity Majors, who is the CEO of Honeycomb. Charity Majors, welcome to Maintainable.
Thank you for having me.
I would like to dive into the weeds a bit. First off, how does your team define and talk about technical debt?
Yeah, so technical debt, I think there's this tendency for people to think that technical debt is the same as bad code. And it's not. Like, we can write bad code all day long that isn't borrowing against our future. Technical debt is stuff that you're doing today that you know is going to cost you in the future, and it's going to cost you more and more the more time goes on when you haven't dealt with it. We will often look at each other and go, is this technical debt or is this just bad code? Because there is some bad code that's been in production for a year or more, and it's great. It's never cost us anything. It works. At some point in the future, it may cost us some in readability or something, but it works, right? The canonical example that I'm thinking about right now is this really awful backup script that I wrote for our databases years ago at Parse, which was in Bash. Now, it didn't cost us anything. For 5 years, it sat there doing its job in prod. If we had ever decided that we needed to extend it or add features to it or do anything fancy with it, then it could have been technical debt because someone would have had to go back and redo it or rewrite it or deal with all that I had done. But it never actually became technical debt because we never actually had to do anything to it. It's such a judgment call, It's something that I think senior engineers kind of have an instinct or an intuition for, and yet can still be wrong about. But I think that just the discussion of, is this technical debt or is this bad code, is one of the best teaching tools that we have.
Yeah, that's a good point. And I think when you talk about bad code, do you have some examples of that outside of your backup script in terms of it's just that it's not readable to other people or?
Yeah, it was done too cleverly, perhaps. Or it was done in a different language than everything else. That's one of the worst. Or it was done just not, it could be using all the idioms and all of the best practices of a different company. Somebody who's new who joins the team, who hasn't gotten a good code review, right? Code review, one of its important functions is bending everything towards similarity. And if you didn't get a good code review, your perfectly good code could be technical debt in a new job.
Yeah, I like that. The bending code towards similarity. I hadn't heard that explanation.
And operability is another big area of technical debt that we often amass without it necessarily being apparent to software engineers that they're doing it because it's invisible to them. It's invisible to them that say that they're patching a bug in memory management. It may be invisible to them that this is going to page someone every night at 2 a.m. when something else runs, or that it's going to make us need to spin up 20% more instances, or when you're writing a database query, wow, technical debt can really be buried there.
Yeah, and when you say operability, can you elaborate a little bit on what that is in the context of software development and maybe deployment and DevOps?
Yeah, so I often like to say to software engineers, because it drives them nuts, that writing code is basically free compared to managing it over its lifetime. Writing a piece of code can be challenging and hard and interesting, but the cost of developing it compared to the cost of maintaining it until it is sunsetted is effectively zero, which is why I think that the lifetime consequences of that code, which I refer to as operability, can never be a second-class concern. Unless you're writing something that's disposable that will literally only ever be run once and then never again. Still, sometimes you're wrong, right? We have this tendency to put things out there without thinking about, how am I going to maintain this? Who is going to have to read it? What are the scalability implications? How do they intersect with the business plan? How do they intersect with our human teams? Is it going to be a different team or the same team who's going to be maintaining it? The area that sits between the code, the users, and the humans and the infrastructure is all the fuzzy meat of operability.
How do you think that applies to, say, an organization that's maybe a startup that is working towards their first MVP or, first couple of versions of their application, and maybe they're incurring a lot of technical debt or not really thinking about the long-term costs?
They're moving fast because most startups fail, and it's not because they move too fast. Most startups fail because they move too slowly or because they stopped and, sunk too much energy into things that didn't ultimately matter, because so much of what you have to do as a startup is disposable. And one of the fun things that I think about joining startups is that you have to move through different phases so quickly, right? In the beginning, like when you're just spinning something up from scratch, you have almost complete confidence every single thing you write is going to be thrown away. And so your job is just to move as quickly as you can. When you're starting from scratch, it's like, how do you work at a startup? Well, you look around, you realize that nobody knows what to do. You pick something and you start running with it. From time to time, you look up and you look around. Is this the same thing? Is this the right thing for me to be working on? And as soon as you realize it's not, you put it down, you look around, you pick up something else, and you start running with it, but like you never stop. Stopping is death to a startup. And never looking up to examine, is what I'm doing the right thing, like, is death to a startup. It's that flipping back and forth between, motion and checking yourself against, your team and the plan that makes, and lots of people find this terrifying, not fun, because we all kind of have attachment to what we're building. We want to see it live a long and prosperous life. And at a startup, you have to be very not attached to what you're building, because it's all going to get thrown out. Except once in a while, it's not. And so within months, you're probably going to transition into another phase, which is, okay, we've got something. Now we've got something. So we all collectively agree that this section of what we're building has promise. And we reevaluate, is what we're working on the right thing, pick up a different set of things. And you start checking in with each other more frequently. But then as soon as you have users, you move into a very different phase. And this is where operability really becomes a first-class citizen, because you can't afford to piss off your users. And that means you have to start thinking about longevity, and you have to start thinking about the impact. You can't just take down the database to, do a schema change. So that's when your code starts to grow up, right? That's when it becomes real code. I feel like any code that isn't encountering users in production isn't real code. It's just a promise of something. And it doesn't really matter. This is why, I always tell startups, there's a continuum of fear that you should think about introducing new things on. The places where you should have no fear is over in developer tools, because it's not touching your users. You can try new languages and new platforms and put your junior kids who are anxious over there to play in things. And the closer you get to storing bits on disk in production, the more fearful you should be, and the more layers of process, the more care you should take, because changes that you make to the storage on disk of things that your users care about can have irrevocable consequences.
Right. That's true. So taking a quick step back, let's learn a little bit more about you. For those who aren't familiar, could you share what Honeycomb is and what inspired you to begin building it?
Yeah, totally. I'm an infrastructure engineer. I don't like software. Software is, the source of most of the problems in my universe. I'm a big fan of red diffs. I love deleting code. Most of my career has been spent kind of in the position of, I will be the first infrastructure who comes in and joins a group of software engineers who think that they've built something that might be real. And I help them help it grow up. I was doing that at Parse. Parse is the mobile backend as a service. It's like Heroku for mobile. I was doing that at Parse, and we got acquired by Facebook in 2015. This was, Parse is really taking off. I think I joined pre-beta. There were about 60,000 mobile apps when I joined. There was over 1 million mobile apps stored in Parse before I left. And we were in this phase of rapid hockey stick growth that every startup really wants to have. But we were dying. We were down every day. Every day, we had this shared pool of Ruby servers, which is a thread per request. We had MongoDB, which only had a single global write lock at the time. Every day, someone like Disney would come and be like, Parse is down. And I'd be like, Parse is not down. Behold my wall of dashboards. They are all green. Everything's green. Everything's fine. Because mobile traffic isn't huge. Maybe Disney's app is doing, 4 requests per second. And I'm doing 100,000 requests per second total. So it would never show up in my time series aggregates. And so I'd yell at them back, and I'd argue with my users, which is always definitely what you want to do. You totally convince them that their shit is in town, right? But eventually I'd go, okay, I'll go investigate, or I'd send someone else to investigate. And it could take us hours, if not days, to figure out what had gone wrong. Because if you think about it, they're writing their mobile app, they're writing queries in their IDE and uploading them to my database. They have no idea what the performance implications are going to be. I have to make them work, auto-indexing and everything, tens of thousands of other apps in the same database, trying to make them not interfere with each other. And they got to write JavaScript code on their laptop and upload it and just make it work, next to all the other apps JavaScript. And I'm just in the middle trying to load balance, right? It was a nightmare. I was just beginning to lose hope. Like, I thought that we had built a system with some of the best engineers in the world doing all the quote unquote right things, that just couldn't be debugged, like undebuggable. And I tried every tool out there. Finally, we got acquired by Facebook around this time. In one of the depths of my misery, I tried using a few Facebook tools, and one of them was this butt ugly tool called Scuba that was aggressively hostile to users. But it did one thing really well. And that one thing was it let me slice and dice on high cardinality dimensions in more or less real time. I started feeding some of our data sets into there, and the time it took us to explain exactly what was happening and why just dropped like a rock, from hours or days to seconds, maybe minutes. Like, it wasn't even an engineering any problem anymore. It was a support problem, which is what you're trying to make it, right? A support problem is predictable. A support problem has bounds. A support problem can be planned for. After having that experience, we moved all of our data sets in there and started using it. And then when I was leaving Facebook, at the time, I didn't really stop to think about why it was, such an impactful. I was just like, yay, tool solves problem. On to the next thing. But when I was leaving Facebook, I stopped short and kind of went, oh shit, I don't know how to engineer anymore without the stuff that we built on top of Scuba. Like, it's not even just about debugging when things are down or for problems. This is my eyes and ears and nose. This is how I know it's happening in production at all times. This is how I decide what I'm going to build. If I'm like, oh, this compression feature, is it worth building? I add some instrumentation, wait a couple days, do some math. Oh, I see. The distribution of impact will be across these users. These will be hurt. These will be helped. This is the sum total storage that will save. This is the performance. And then I'll go build it. And as I'm shipping it, like, I have an eye on all the instrumentation, like, so that I'm validating that what I think I just shipped is what I actually shipped, and it's working the way I expected it to. And I'm looking around to see if there are any other side effects. It's like if you're really blind like me, it's like suddenly putting on glasses one day and everything just becomes clear. I can't imagine going back to having just the big, dumb monitoring checks and, these very rough heuristics about whether or not something is broken. It's actually unthinkable to me. So that's why we decided to build Honeycomb, was just out of that experience. It was so powerful. Christine, my co-founder, was also at PAR. She was on the other side of the room from me. She worked on the front end, and she built our analytics product from scratch. And she had the experience where we built this analytics product for engineers for the world. They kept wanting to do things with it. It was a time series aggregate. They kept wanting to do things that we couldn't support. So she would have to fall back to Scuba to ask the questions, because fundamentally, it's about observability, which means every engineer out there wants the ability to ask new questions, like any question, anything that comes up. They want to be able to ask and understand any new scenario without having to ship new code. Because if you have to ship new code to ask the question, you're kind of having to know what the answer is before you ask the question. So working back from that is what led us to, observability and to all of the things that are making up Honeycomb.
Is this a service that you're offering to other companies now?
Yeah, it's a service. There's the Scuba white paper is out there. You can read it. I did a Papers We Love talk about it. We based our storage engine on that. Spoiler alert, there's nothing out there. There's no storage engine or database that will let you do these things, with arbitrarily wide events that you're slicing and dicing in real time to call and restore. So we had to build that. Once that was built, we started thinking about the human side of this. And this is where things really get exciting, to me at least. We don't build for individuals. This is distributed systems. No node can go down, right? And fuck everyone. So with teams, we've gotten to this point where systems are so complex. Each of us has an area of expertise. And so very often that means that none of us can go on vacation. Like, nobody can go and just be completely offline. So we build for teams. I learned Unix by reading other people's bash history files and just trying all the commands. So we baked that into the UI of Honeycomb, where, my history is there. I can see every query that I've ever issued, and I can see the ones that my team has issued too. So, like, if I get paged one night at 2 a.m. and I'm on call and it looks like a Cassandra problem, but I don't know fuck all about Cassandra, but I know that, like, the experts on my team are Christine and Ben. And I think the last time we had a problem like this, it was maybe 3 weeks ago. I think Christine was on call, and I think she dealt with it. So I'm just going to go back and look. What questions did Christine ask? What queries did she issue? What did she think was meaningful enough to post to Slack? What comments did she add? What queries did she think were, when she did a postmortem afterwards, which were the meaningful queries that she gathered into a collection, like put some tags on, it's like, oh, here's the postmortem for this one. Our systems, when they break, they don't rhyme, or they don't repeat, but they rhyme, or however it goes. Just looking at the grooves that have been worn in the system, the way experts interact with it in their particular area, and giving access to the team, it creates this wonderful, like, hive mind where I can go on vacation, and the parts of the system that I'm responsible for if other people need to ask questions about them, they just look at it. How did I interact with it? What did I do?
That's really great. It's interesting because I think about the history thing and when we've worked with different servers, even just like what's one of the most common things that junior developers seem to pick up when I'm pairing with them is like when they're watching me look on a server or even look on my own local development machine is like how often I'm using just the history command and using grep on that or something. And I'm like, I think I did this before. This sounds familiar. I think that's often overlooked. Like, what did we do in the past? And
it totally is. Like, we're such social animals. If you're trying to learn something new, the hard way is to like drag out your books and start reading the source code. The easy way is to just imitate each other. I feel like it taps into our sense of playfulness. We all we know who the experts are and we want to imitate them, but we're kind of shy. And if you can just look at what they did and copy them and tweak it, I find constructing queries extremely difficult. I don't use graphs easily. It can take me hours to try and reconstruct something that like Ben, who's I've been working with for 10 years, right? He'll be up late into the night crafting this perfect, beautiful graph that represents reality. And then I wake up the next day and I bookmark it, right? Because I can take those and I can tweak them. I feel like all of us, even the fairly non-technical people, can tweak graphs. And so what we need to do is take the Bens of the world who love playing with things visually and give them more impact by making it easy for other people to imitate them and copy them and then tweak what they've done.
I like that. That's a good perspective there. I have to think about that a little bit in terms of interacting with we have like interns in our office and just, I think there's not enough sitting with each other and working on things, but pairing with different developers. But also it seems that when they can just spend some time sitting down and like watching how I might approach something or how another experienced developer approaches something, like they seem to just pick up so many different things.
Totally. Because you're not aware of what you're doing that's different or expert, right? And if you try and write it down for someone, you're not going to capture most of what's interesting to them because you're not aware of what's different and interesting to them.
That's true. Kind of like a side tangent there. One of the things that I've started doing recently in terms of like sharing how I'm doing things is trying to like, I have this problem I'm going to help out with. Why don't I fire up a screencasting tool and just record the screen like so people can see what I'm doing? And if it takes me like 5 minutes to figure something out and maybe there's some value at the end of that, I'm hoping someone will watch this again one day.
Yeah. Because they get to see all the things that you tried that weren't valuable too, because maybe next time that will be the thing that's valuable.
So last year at ChaosConf, you raised some eyebrows when you said testing in production has gotten a bad rap, and trying to mirror your staging environment to production is a fool's errand. Just give up. What led you to this?
Well, I do like throwing bombs, little bitty bombs. And that's not 100% true. I never 100% agree with anything that I say. What led me to it, though, was realizing that I think that every single company I've ever seen has spent, like we all have a fixed number of engineering cycles. Almost all of us are spending way too many of those trying to prevent problems from ever making it to prod. By doing so, we're starving ourselves of the cycles that we need to quickly detect and remediate and experiment in prod. Like the tools that we give people for production are bare bones to non-existent. We don't build guardrails. Any place where people are scared to deploy is a place where that is the lowest hanging fruit. That is the thing that your engineering cycles should be spent on, because deploy code is the most important code that you will ever write. And yet we give it to interns and we don't make it safe. We don't make it so that people feel safe doing it. And that to me is a big problem. And I think it's really holding us back from a number of our goals in the industry right now. And to be clear, I'm not saying don't test. I'm not saying that there is no value in staging environment ever. I'm not trying to say any of those things really, as so much as I'm trying to say we need to take a fresh look at how we allocate our engineering cycles when it comes to pre-prod versus post-prod. Because I think this plays into a lot of our human biases. We have this idea that we can prevent failure, but we can't. We just can't. We can't, and we should embrace the fact that we can't, because it is good to practice small failures often. It's good for the people. It's good for the systems. It's good for the processes. It's like your immune system. It should be regularly stressed.
How do you account for that? I know that I'm just thinking about organizations that have support teams, and when they're the one, like the support team needing to be the ones that have to maybe bear the brunt of.
So they shouldn't. Like the golden rule here is users should never notice. And really, your support team should never notice either unless they're looking for it. Your system should be able to tolerate so many overlapping failures before a user ever gets an error, right? And putting the focus on that, I think, is what helps. Like in your support, their pain should be aligned ideally exactly with the user's pain. If the user's not in pain, support shouldn't be in pain.
Okay. In terms of like maybe giving like a tangible example, let's say you've got a mobile app or a web application out in production, and let's say your Cassandra instances go down, and
let's start with deploying your app. Let's say that you've got your app and you're deploying it and it's crashing. Well, ideally your deploy script would see that it is crashing, or maybe there's a canary group or a first tier, that you deploy to, and they can all crash and your users are never going to notice. So it would detect that your app is crashing and it would roll back, or it would put up a flag, be like, I need some help. I'm a big fan of progressive deploys for this reason. So like the way Facebook would do this is they would deploy first to internal. So Facebook went down all the time for us internally because we got the brand new deploys, but it would never go any farther, obviously, because that was acceptable. So if it passed, the internal test, then it would get deployed to like 10% of Brazil. I don't know why it was always Brazil, but it was always Brazil. And then would let it bake for a while, right? So the trade-off here is certainty versus speed. You can be very, very sure of your deploy and you can have it all be handled automatically if you're willing to let it take some time. And if you aren't, then you can't. Every company, as they grow up, they kind of pass through this event horizon where they start to care about its stability more than its speed.
That's true. How do you feel about engineering teams where the engineers are kind of primarily working on, say, new features, new whatever process they're following, and they kind of pass that off to the next path, going through testing and stuff, and then they're pretty far removed from that code ever getting deployed, and they're kind of then moving on to the next thing.
Yeah, I think that's terrible. I think it not only makes for bad organizations or bad engineers. I think that pain is nature's tool for teaching us things, and I think that all software engineers, I'm going to use a very sweeping statement here. You can pull all kinds of holes in it, but all software engineers should be on call for their code. And this can be done in a number of ways, right? It doesn't mean you have to do it 24/7 for a week. There are lots of different configurations, but I feel like the only way that you build a senior software engineer is to expose them to enough of the consequences that their gut is true, that they have an intuition for what's going to be harmful and what's safe, even before they start to unpack it. And I think that you have to expose them to consequences for that. So I think that I'm much more of a fan of organizing teams so that they're organized around a product or a function, right? And they manage it from end to end. And then, maybe it moves off into stable territory, but while it's being developed, and that I really like the pattern where you have groups that have, a designer, a couple software engineers, an SRE, PM, who are all just, managing that, building that thing from end to end. And I know that that's kind of a pipe dream that not everyone can achieve, but I feel like that feeling of ownership, we're moving towards this as an industry because it builds better services. It builds higher quality software for our users. And that's what we have to work backwards from, right? What is best for the users? Well, it's not having one guy write a piece of code and have it hop through half a dozen teams and a month later emerge out the other end when nobody has any context on what was built and at the managing it side of the pipeline,
And then they're left being the ones having to deal with trying to figure out what's changed. And
yeah, eventually it's going to get back to them, but it's not going to be in a good state. They're not going to have remembered what their original intent was. It's bad for everyone. And we've got these organizations that are operating under decades of accumulated technical debt from this pattern. It's hard to unwind from, but it's absolutely necessary.
One of the things that we've tried to, we're a much smaller team. And so our developers are the ones actually deploying and needing to deal with, the production implications that happen. But I think what I find is sometimes we'll be working with a client on building out some new features or something, or making some performance improvements. And I feel like there's not enough of an emphasis on what does it mean to complete that feature? Is it just when it gets deployed, or is it actually and gets approved that it's been deployed and it seems to be running? Or is it that once they've been able to also then measure how that's actually impacting the product, how it's maybe benefiting the users? Or
a deploy is just the beginning, right? It's just the start of you starting to validate what you've built. It should never be seen as like the end. Now we've deployed it. Now we can start understanding it, right? Because until then, it's all in your head. It's not real until it hits users. Every pull request should have, the question, how will I understand if this is working? And then after you've deployed it, you go and you look. Can I understand that this is working as I expected it? And you let it bake for a while. The longer your code has been running in prod, the more confidence you can have in it. One model that I've seen work is once you get past a certain size, you do have to have like an SRE type of org, people who are experts in operability, who can kind of consult at the very least. Because you can't ask software engineers to have two jobs. Their job is to build good code, and that includes the operability lifecycle. Their job is not to be experts in operability. one pattern that I've seen is that after the SRE team agrees to take on the software, then they will run it. But that's after it's reached a point of maturity where it's been run by the people who wrote it for long enough that everyone has confidence that running it should be just, you apply this pattern, it matches all the other patterns, you can run it as without having to think too hard about it.
Nice. So on a people-centric level, how do you build a culture within an organization that's less reactive to issues and, say, holistically more constructive?
I think it starts with looking at what you praise. Anything that you praise in your organization, you're going to have more of because people want to be doing what is seen as valuable. And I've had to edit myself away from praising things like, oh, God, you were up all night shipping this feature, right? No. You could maybe thank people privately, but never praise them publicly for doing things like that. And you have to make visible the things that you do want more of. And this is management's job. And it's not as easy as it sounds because you have to go looking for the things that are not visible. You have to praise people for, oh, thank you for building this, ahead of schedule. Thank you for having this clean release where no fires went off. Thank you for the bell that didn't ring. Thank you for taking care of yourself. Thank you for spending this week mentoring someone else when that was the most important thing. I think that just being very conscious about what you praise is key. And the next step after that is what do you promote on? If these three things aren't in alignment, you're going to have a really bad time and people are going to be very frustrated. If you praise in the right things and you promote on the right things and they are the right things, then everybody kind of knows what's expected of them. They're not going to be frustrated and they're going to feel on their daily level like what they do is in sync with the broader whole. But if you're praising people for firefighting and promoting on writing complicated features, people are going to be super upset.
It's true. It's an important thing, I think, culturally for an organization to kind of reflect on at times. And I know, for example, one of the things that I've tried to do, I really discourage, say, employees sending emails outside of normal working hours as an example, really basic. It's regardless of even just being developers, especially with clients, because I don't want clients to think that we're always available, kind of at least provide this sense of illusion that we can keep a normal, 9 to 5-ish schedule and still run a pretty smooth business. But then there's also that when a PM or something is checking in on something over the weekend because they just decided that that's something that they wanted to do to get something done, I don't want to necessarily highlight that as thank you for doing that in public, because I think it's a good perspective to think about it. And I think that can often be an easy thing for people to kind of recognize, but it also, I think, can maybe set the expectation. What is it saying to other people? Oh, if I want to get praise, I need to spend more time on the weekends working. And that's probably not what you really want. So,
yeah, we're very hierarchical creatures, even those of us like me who kind of reject and resent that. And the higher you are in the org, people are going to be scrutinizing what you do and attributing way more meaning to it than you do yourself. There's just no way around that.
That is true. When you hear an engineer say, we should rewrite this, what sort of things does that conjure up in you?
Oh, God, no, why? It's terrible. And yet, I've been through a couple of rewrites that did need to be done, but it sounds easy and it never is. It never is. It always takes 3 times as long as your worst estimates, and it is painful and it breaks in a million ways. We had to do a rewrite of our API from Ruby to Golang about 2 years in, and we knew it was going to be painful, and it was far worse than we thought. In this case, it did probably need to be done. Our fundamental tech stack was Ruby on Rails, single thread per request. We needed something that was multi-threaded because if any one of those backends got slow, all of the workers would immediately fill up with threads that were waiting on that backend. We tried a million hacks around this. We tried all sorts of things, and we finally realized it was going to have to be a rewrite. It was either JRuby or Golang, and if we chose JRuby, we would still have to rewrite all of the gems because none of them are thread safe. It didn't seem like less work, and it seemed like it would be a detriment to recruiting, whereas Golang at the time was hot and really helped us recruit. So we did it. It was excruciating. All product forward momentum stopped for almost 2 years.
Oh, wow. What was the worst case estimate that you had started off with?
We had thought it would be under a year.
Okay. And what did it end up taking?
Over 2 years, probably 3 years. And in fact, we finished right before shutting the service down.
Oh, of course.
Of course. Yeah. Rewriting is always hard and painful. It helps if you have the people who are originally there, who have the original intent still in their heads. Another reason that it was hard for us is that our senior engineers all left around that time and we had to replace them. So we were very much like cargo culting. So, Ruby has all of these implied types and so forth, and Go is very strict about these things. And so when we started shipping changes, we realized that all the mobile apps out there in the world were freaking out because types changed. So we wrote this thing that just split traffic. So every request that came in the system, it would split and send a copy to the old Ruby API and a copy to the new Go API. And then it would diff them, print out any diffs, and return the Ruby result. So the user would never see any difference. And then every day you just go back and see all the code paths were hit, they had any differences. And then when we moved on to database mutating ops, we changed them so that you could spin up a copy of the database on both and have it write to both the Go API and the Ruby API and return the differences. And this was absolutely invaluable. That was the only way that we could have done it.
That seems like a really useful pattern to approach there. Let's say there's an engineer out there listening to the podcast who feels like they're maybe a little too far removed from production, and maybe there's some bureaucracy, at least perceived bureaucracy, for why they're not going to be able to ever really get to interact with the production environment or be part of that team, maybe to work closer to the operation side of the software. They're really curious about learning more about that. What sort of advice might you offer them to approach their management or their peers on trying to advocate for themselves and or their team?
That's such a good question. So when it comes to ops teams, in my experience, we are all so happy when software engineers care and when they want to sit with us and learn things and carry the pager. Offer to carry a pager and you will be their friend forever. On management side, I think you just have to make it clear to them that how much they're suffering. So much of being a senior engineer or a manager, I think, is looking around, paying attention to the pain that is not being felt. We make our decisions based on, evaluating, is this more painful than that? But there's so much pain that never gets appropriately surfaced to decision makers. Somebody on Twitter last night was like, what I'm struggling with right now is when we don't fix things sooner in the life cycle, the problems that happen are worse. I'm like, well, then you need to surface that pain to people. Sometimes it's just complaining about it or sending an email whenever you see it. But I think that one of the most useful things that any senior contributor can do is look for where decisions that are being made that are not the right decisions, and then look for the pain that is not being felt and look for ways to amplify that or magnify that or surface it to the right people, right? Sometimes it's just being buffered by another team or by it's sending an email, but it's getting filtered in everybody's email clients, so you have to put it somewhere else. But I feel like looking for pain to be amplified is super important. For the engineer, who's trying to convince their management, look for that pain. If you have a system that is paging people, 4 or 5 times a night, but they're used to it and they're numb to it, that's a broken system. Your system should not be waking anyone up, let alone 4 or 5 times a night. And yet teams do grow to just take it. One thing that I saw was a manager got paged every time the team got paged. Well, that got fixed very quickly.
All right. So 2 final questions. What book do you find yourself recommending to software engineers most often?
Sapiens is a great book. It really helped me for dealing with humans. There's my database reliability engineering book, which is, I think, a pretty good read for engineers. A big part of what engineers need to learn about operability really comes down to data stuff. So that's a good one.
And where can people learn more about you and Honeycomb?
Well, we have a blog.honeycomb.io. And we write a lot of the cutting edge stuff on distributed systems, observability, teams, how to work together, how to get from, point A to point B. There's some really great stuff there. And my blog is on charity.wtf and Twitter, of course, Bipsy Tipsy.
Well, thanks again for joining us on Maintainable, Charity.
Yeah, this was super fun. Thank you for having me. This is great.
Maintainable.